Hello everyone. So now let's start with the next important topic, that is UART. So it is also I will be explaining from the interview perspective what questions will be asked and the basics of UART. And from my last video over I2C, I received one comment and one question from it. So I will be explaining, giving the answer to that question. So let's look into it. So the question is, what if two masters are trying to access the same slave? How does bus arbitration works then? So first thing, let's understand what happens is the slaves are connected to the two common line. Okay, the slave doesn't care which master is sending. Suppose you have two more master, m1 and here m2. Now it doesn't matter which master is sending the data, as long as the data is for the slave 3, the slave will receive it. So from the master perspective, what happens? Let's suppose both the master wants to send the data to the slave 3, which has the address 0 cross 03, and in binary it is 1 1 and 0 0. Right? Now, let's suppose M1 wants to write to the location 0 cross 0 or 3, and M2 wants to write to location 0 cross 02. So what data will be sent over this SDA line, over the data line? Let's see. First, it will send the start bit, then it will send the slave address, then it will send the write bit, then it will send the address where it wants to write. So up to start bit it is one, slave address is same 0011, and write bit is 1. So the entire data for both of them will be like this: 1001111. Up to this it is same. After this, m1 will be sending the address as 0011, and m2 will be sending the address as 0010. So here also 0011 and then 0011100010. So ultimately the slave 2 will win the arbitration as it sends the first 0. Okay, so this is how the thing will work. And here the master m1 will stop sending the bit as it like it loses the arbitration to the m2, and finally m2 wins the arbitration and the data flow continues from m2 perspective. Fine. So this, I hope it clears your doubt. If further anything, please do the comment. Okay. Okay, now let's look into UART communication. What is UART communication, how it works, and from the interview perspective. Okay, so first thing to understand, UART communication is a two-wire communication, provided that both the devices are at the same ground level. Okay, so here also the two wires are pulled up to VCC, so it can be pulled up to 5 volt or 3.3 volt. Just remember that they are always pulled up. Why this is done? In order to understand that these lines are working. If there is a breakage, then it will not get pulled to VCC. Okay, so in that way it is always pulled up to VCC. Now the data is transmitted by TX and received at RX. T means transmit, R means receive. So whatever data is transmitted from TX will go into RX. Similarly, for this device, whatever data is transmitted will go into the RX. Then one more thing. Here, the UART communication always happens between two devices. So you can only have two devices. It's a serial communication that happens only between two devices. There we cannot connect more than two devices in an UART. Okay. So now the questions come, why then we are using the UART communication? So UART is a very common mode of communication. You remember USB, it also is a serial, universal serial bus. Okay, now you remember previously we used to have printers, then mouse, all uses this UART communication as a serial communication. So whenever we want to communicate to a PC, we are using one controller. Suppose you have a controller and you want to communicate to a PC, then the best option available is a UART communication. So you just connect the USB cable and you have a USB to serial converter. Then it gives you the data over the UART. So UART is the most commonly used, and it is very easy protocol which can be used by anyone for communicating. Okay, now let's look at how the frame looks when we are communicating in UART. So it is very common thing. Like whenever you transmit some data over UART, it will just transmit it in this direction like this. So this is how the UART data flow happens. Now you may have a question that, okay, then how the other device knows that when it needs to capture the data, right? So the basic question is, suppose I am sending bits like this, okay? So how I know that this is one, this is the one, then this is zero, then again zero, and this is one? How I know what is the interval from between which I need to check what is the data on this TX or RX line, right? So this is achieved using baud rates. So let's first see how the data frame is. Okay, let's first understand what is their properties, otherwise it will be confusing. So first property is UART is a two wire communication, first thing. Then it is used using baud rate is configurable. What is baud rate? Baud rate means you are basically sending the speed, like how many bits you will be sending every seconds. Okay, when I say 9600 kbps, sorry, it's kbps, then actually we are sending 9600 bits per second. So from this you can understand how much time interval is taken between one bit, simple mathematical calculation. And this is how both the devices will be at the same baud rate, both of them will be working at 9600 baud rate, otherwise the data will never get matched. And at that time, you know that what is the interval, at what interval you will be receiving data. So you will look into this TX line or the RX line from this end, from the D2 end, and you will start capturing the data. Okay, so this is how it works. Now, what is the basic format of data that we will be having in UART communication? So the basic format is, we will be having a start bit which will initiate the transaction. So any device, whether it's D1 or D2, can start the start bit and start the transmission, and then it will send the data bits. So you see here there is a start bit, and then there are data of 8 bits, then there is a parity bit and stop bit. So start bit is to start the communication, then data bit is the actual data, parity bit is for the, you can say it's for error check. So what is parity? I think you may know that there are two types of parity, even and odd parity. So basically you are trying to maintain total number of one that is transmitted as even. Okay, so suppose your data is like 0 0 1 1 0 1 0 0. So the total date in this total data, the number of one is 3, so it is odd, and you want to maintain an even parity, so you will set the parity bit as 1. So that means you are always maintaining an even parity, and this same configuration has to be done on both the ends. This configuration should match on both the ends. So this slave also knows the parity is even, and this also knows the parity is even. So when it receives the data, it will just count the total number of one from parity bits to this, and it will check, okay, the total number of one is even, that means it's an even parity, and the data received is without any corruption. So it is a very basic um, error check that is happening for checking whether in during transmission the data has get corrupted or not. Okay, in and at the end, to stop the transaction, you have the stop bit. Okay, now, so this is a two wire communication, this is clear. Then what is a baud rate? Baud rate is between the two devices at which the speed of transmission will be there. Okay, for the baud rate only helps to synchronize the data between them, because otherwise, suppose one device is sending at, like, say, 1000 like, let's say 10,000 bits per second, and you have set the baud rate at 9600. So what will happen? So for this device, the data per the time interval between per data will be less, and for this device the time interval will be more. So it can happen some data is like this, and one device is scanning at this place and another device is scanning at this place. So it is trying to send one, but ultimately you end up getting zero. So this mismatch will happen. It will never stop the communication, but the data what you will be receiving will be wrong data, basically. So the configuration should be same on both the ends. Always remember, in a UART configuration, both the devices should be configured in a similar way so that the communication happens. Now let's look at the next thing. This is a serial communication and asynchronous serial communication. What does it means this is synchronized with with the help of the baud rate, nothing else. Then only two device can be communicated, as I showed. So only TX is connected to RX and this RX is connected to TX. So it's a two device communication. You cannot connect D3 and can send a different data to D3. No, it's not possible. It's only TX and RX, and there is no device address. There is no device address concept here. Okay. Now the next thing is, as I told, that both the lines are pulled up so that it understands that the lines are operational. That's the only thing, that is, it is pulled up so that the lines are considered as operational. Then data can be sent and received at the same time. This is very important thing, okay, in a UART communication. Why UART is used so frequently? You see, there is a dedicated line for TX to transmit the data. Okay, let me just clear it. So there is a dedicated line for TX and a dedicated line for RX. So when D1 is transmitting some data, D2 also can transmit the data, because D in D1 this RX line is free. It doesn't matter if TX is transmitting or not. Similarly, on this side, when RX is receiving some data, TX can also transmit the data. So here the transmission and receiving can happen in same time, and that's why this is also called as duplex duplex communication. Okay, so this, I hope this is clear. So let me just show you how it looks. So I hope my screen, okay, this is fine. Okay, so here you see that I told you we have, first thing is baud rate to configure a UART on an IC. So I am using STM cube 32. So you have different baud rate. You can just click and change the different baud rates. Then you have the parity bits, the word length, that I was telling, that how many bits of data you will be sending. So here I have shown you this one. Sorry, this one, data bit. So what will be the total size of the data bit that you can send? So here you will be configuring whether it's a 8 bit. It is saying that including parity, then it should be 9 bit. 8 bit of data and 1 bit will be the parity bit. Then what all parity bits are there? So it can be none, even, or odd. You don't want to have any parity in it, so you just say it's a none parity. Then stop bit can be 1 or 2. So next 2 bits you can configure as a stop bit. So so the data knows that it is a stopping. Okay, and some advanced parameter is data direction. So see, here you have receive only, transmit only, and receive and transmit. So this is duplex, this is half duplex. Either you will only be receiving data or you will only be transmitting. So every time we normally use receive and transmit for the UART communication. And there is oversampling. So this I will be explaining further. Okay, so now let's go to, this is also, there are some questions that are generally asked from UART perspective in interview. First thing is, what are the parameters that we need to configure a UART communication? Very important question that are asked. First thing, baud rate. So baud rate is the one which decides at what speed the communication will start. Okay, so this, just remember that baud rate is very important in it. So it is the rate that is fixed between two devices for communication. Next is the word length, that is 7 to 8 data bit. Okay, then there is a parity bit and there is a stop bit. The same thing I have mentioned what is required here to configure the device: baud rate, word length, parity, stop bit. Okay, these are the basic parameter that you need to configure to start a UART communication. Now the next thing is, what do you mean by oversampling rate? Another important question. And you see, it is in advanced mode. Sorry, it's in advanced mode. That is here. What is oversampling rate? So what is oversampling? Let's read it. The incoming data on the RX line are sampled at 16 times the baud rate, or whatever sampling time you are setting. The process of oversampling is as follows. So you just read the whatever definition I have given. I will just explain you what happens in it. So let's suppose you start a communication. There is a start bit, and then the data is started coming. Okay, some data is coming like this. Now, in order to reduce the error in reading, what happens? Suppose I said that the data will be coming after an interval of, let's say, 1 millisecond. After every 1 millisecond you need to scan the data. So what you will do, you will divide this 1 millisecond in 16 by 16. So you have very small 1 by 16th of a millisecond, and at that time, whenever there is a start condition, you will start a counter that will be counting at this rate. Like at this speed it will be incrementing very fast. Like if I say 1 by 16, it's something comes around how much, 1 divided by 16, so 0.625, so it comes around 0.0625 millisecond. So at this speed the counter will be running. So what happens here? So whenever there is a start bit coming, at that point the counter starts. So it will start here 1 2 3 4, like that it will start. So let's say the counter is of 16 bit counter, sorry 16, it's a oversampling rate is 16. Okay, so it will count to 16. So but when the first start bit is triggered, then the counter only goes up to 7. So it will start from 0 to 7, so the counter reaches its midpoint. So at the middle, so at that time when it reaches the middle, I we can assume that this is also the middle of the start condition. So here the counter value is 7. From here the counter will reset itself and again it will start counting from 0. Okay, now what, look carefully what happens. Now it will count from 0 1 2 3 up to it will go to 15. So at that time the device assume that when it reaches 15 it should reach the middle of the next bit, and at that moment the data will be captured. Okay, you know that this is the middle of the signal. We don't want to capture the data at this instance or this instance. We want to capture the data somewhere here, where we know that here here it is very correct, because the data is not actually digitally like this. It will be at some voltage level, so the data actually looks like somewhere somewhat like this. Okay, so if you want to capture here you will end up getting here, or you want to capture here you end up, you always want to capture the data in this position. So here the concept of sampling rate comes. So you want to take a sample here and then you want to capture it. So once you have taken the sample, you move that reading into a shift register. So what does a shift register does? It will capture the incoming frame one by one and it will push the data one by one into register. It is just like this. I will just show you. I hope this concept is clear. So I will show you what how does the shift register works. So the register will be like this, and you have total 8 bits of data. Let's say, okay. Now, whenever you have sampled the first data bit, let's say the first data bit is 1. So you put here 1 and you shift this register to left side to one more bit. Now, this now the pointer comes here at this moment. Now the next data is also 1. So you put it 1 here and you shift it here. Now the pointers come here. Now the next data is 0. So it will move 0. So it will receive the data bit by bit, and simultaneously it will start filling this register bit by bit by shifting it to either to left direction or to right direction. Okay, so this is the concept of shift register. The data will be captured bit by bit and it will be put into a register by shifting the register. So let's see, in this way the definition start at the beginning of the start bit the counter starts. When the counter counts 7 means it at the middle of the start bit it reset itself and again starts from 0. Next time when the counter reaches 15 means it reaches the next bit middle. That I told you, right? When, if suppose this is a start bit and this is the next, so if it is at the middle and from here it will start counting to 16 times, so when it is at 15 it reaches the middle of the next bit, and at that time the capture will happen. The data retrieved and is moved into a shift register. The counter resets and start again from 0. So what happens at this moment, the data will be shifted to the shift register and it will start again counting from 0 for the next midpoint of the data. In this way the data will be captured bit by bit into the shift register. Now the next important thing, question is, how many device can be communicated with UART? The answer is only two device. That there is TX and RX line. There is no device address, so only two device can be connected. And the last question is, what is meant by hardware flow control? So this is some advanced level question. So if it is asking, there are a lot of interviews where this is asked, so I am explaining it, but it is very advanced level thing. So let understand what is happening. Now suppose you have one device D1 and another device D2. This device is having, let's say, i7 processor, and this device is some old, let's say, i3 processor. So this is a slow device and this is a fast device. So the fast device is sending the data at a rate, both the rates are same 9600, and this rate is also same 9600. But when it sends some data to it, this device needs some time to process the data. Okay, so it is sending the data at this speed, but at this end, let's say the device is saying, okay, I already received some data, I need to keep into the shift register and some process the data. So to do this device needs some time. Okay, at that time this D1 will not stop sending the data, correct? It is sending the data because this device don't know whether this D1 D2 is busy or not. So what D2 wants to say to D1, okay, I am now busy, please pause the send or pause the data for some time, and then when I am free again, I will be sending you the request to send the data again. So in that way, if a fast device is trying to communicate to slow device, to reduce the loss of data, we have two things. One is CTS, that is clear to send, and one is RTS, request to send. So if D2 is sending the data, then D2 will have clear to send signal, and when D2 is free, then it will send the message that RTS saying that I am now ready and please send the data. So hardware flow control is very simple. It is only to do only to be done when there are two devices, one is fast and one is slow. There will be two pins, CTS, RTS. Similarly here CTS and RTS. So slow device will say, okay, I am clear to slow device will send a response request to send, then fast device will continue sending. And if the slow device is saying that I need clearance to, fast device is saying that I am need clearance to send, then it will continue to send the signal that clear to send, right? That. So this is how the communication works between one fast and a slow device in order to reduce the loss of data. So I hope you understand. So if you have any questions, please do a comment. Okay, and one more thing, please do subscribe the channel if you like the video, so it also encourages me to make, because it's something also helps me to read new things and make more important videos for you. Okay, thank you.